Hello everyone, my name is Amos, working as Assistant Professor in the Department of MCA, MIT, Mysore. Before starting with the subject, let me introduce about the vision and the mission. A vision statement is an inspirational statement of an idealistic emotional future of a company or an organization. Vision describes the basic human emotions that a founder or a founders intends to be experienced by the people of organization interacting with them. Whereas the mission statement is a short statement of why the organization exists, what its overall goal is, identifying the goals of its operation. Now we know the vision and mission and its importance. In this view, the Institute of MIT has come up with its own vision and mission. Let us go with the vision of the Institute. To be the recognized as a premier technical and management institution promoting extensive education, fostering research, innovation and entrepreneurial attitude. If this is the vision, the missions to accomplish this vision of an institute is as follows. To empower the students with indispensable knowledge through dedicated teaching and collaborative learning. To advance extensive research in science, engineering and management disciplines. Next, to facilitate entrepreneurial skills through effective institute industry collaboration and interaction with alumni. To instill the need to uphold ethics and in the every aspect of the matters. To mold holistic individuals capable of contributing to the advancement of the society. These were the vision and missions of the institute. Keeping the vision and mission of the institute, department has derived its own vision and mission. Let us look into the vision of the department. The vision of the department is to be the premier source that provides a transformative education to center or to create computer professionals, competent entrepreneurs and technocrats to meet the global challenges. In order to achieve this vision, the mission of the department is as follows. To facilitate students, to nurture skills, to participate their professional competently to meet the ever-changing needs of the society and environment. Next, to develop the potential of human resources with new ideas, research to meet the requirements of cutting-edge technology. These were the vision and mission of the department. Let us start with the discussion with the subject, that is a multimedia system. The subject code is 18MCA541. This subject is offered as an elective by the VTU prescribed course for the 5th semester MCA. The modules of these subjects are as follows. The first one is Introduction, Media, Data Streams and Audio Technology. Here we study about the basics of multimedia, various types of medias, data streams, that is a package and other movements, and also audio technology is discussed. And in the module 2, images, graphics, video technology and a bit of animation is also discussed. In the third module, we talk about the data compression, the need of a compression, types of compression, etc. In the fourth module, we discuss about the optical storage, where different types of storage, types of formats and the efficiency of various storages are classified and discussed in the module 4. In the module 5, it is about the various types of data, their file formats and the standards used by the multimedia objects are discussed. These are the various modules that we are about to see. Next, exam pattern is as follows. This subject constitutes the internal marks of 40 and external exam would be conducted for 100 marks, whereas the 100 marks is converted into a 60 marks. So this subject a compromising of two concepts, that is the internal of 40 marks and external exam of 60 marks constitutes a combination of 100 marks. That is the weightage of the subject called multimedia systems. Now, let us look into the objectives. What is an objective? Means the intention of introducing this subject to the course is the systemizing the key components of the media. When we talk about media, it is a technologies, that is including the text, graphics, motion pictures, video concepts, animation, etc. Next, the approximation or the uprise of the online with respect to the web development environment is also introduced, and it would be discussed, and the familiarize of each media type and their significance with the application and the file formats. And finally, the objective of final objective is to edit the interactive web pages and incorporate the various digital medias. Outcome. When we talk about the outcome, at the end of the course, what would the students get from this is the outcome. The first outcome goes like this: understanding the concept of multimedia technology, where students will be thoroughly understanding the various concepts that would be dealing with the multimedia concepts. Second, learn the concepts of various digital media, means we are totally in the digital world, so various digital media concepts will be familiarized by the students at the end of this. Third one, to know the fundamentals of data compression. So today's world, it deals with a huge enormous amount of data. There is usually a need of data compression. By the end of this course, students will be able to know the concept of data compression. And finally, acquire the knowledge of optical storage. Today's world deals with a huge amount of storage, retrieval and transmission of data. That will be familiar. So students will be able to achieve these outcomes at the end of the course. Next, we see next question arises: why do we need to study the subject called multimedia? Multimedia technology applies interactive computer elements. When you call about computer elements, it might be a text, graphs, videos, sound, animations, or the combination of all these things, information combined to one media for a beautiful representation. So to make all these presentation efficiently, we need multimedia. The multimedia programming enables the students to learn the computer programs and create interactive sessions or interactive materials of presentation. So this helps the students or promotes the students to learn this subject. When we talk about these things, it also stimulates the student's mind or the persons who is using the multimedia concepts. It stimulates, and retention rate is very high. Next, now let us look into the various elements. When we talk about the elements, there are 10 elements. First one, is Facimal. Second one, is the document images. Third one is the photographic images. Fourth one is called GIS or GIS maps itself. Next, it's voice commands or voice synthesis. Next, sixth one is audio messages. Seventh one, it's video messages. Next is full or live videos. Next we have holographic images, and finally we have fractals. So these 10 are said to be the basic elements of an multimedia. Let us go one by one. So first is a facsimile. Facsimile is the oldest or a conventional way which was used for transmit the documents from one place to another. By the time the improvisation of a technology, it's been converted with a well-known concept called the fax technology. Second one is a document image. The document needs to be converted into image because of the reason it needs to be stored for a long period of time, or the long period of transmission needs to be done. Sometimes these images needs to be accessed by n number of people over the n number of situation and with different location. At that time, these document images helps to be used by multiple people at concurrent time and concurrent places. So rather than avoiding the multiple copies and at the different location, avoiding the redundancies. And next is a photographic image. The photographic image is the concept is well known, used, which has been captured by the digital video devices. These images are used by the security the help desk to identify the objects in the real estates and also in the medical domain, where the disease and other properties of the medical concepts are photographed and preserved for the further discussion or verification, or it is kept as a document or an evidence. Next is a GIS. It is also called as Global Information System. Sometimes it is referred to as GIS maps, where the images are captured from a very high altitude through satellites. These pictures are very much helpful to know the geographical statistics. When you say geographical statistics, the high altitude pictures helps to understand the locality or a region or a particular space with respect to the various building infrastructure. Sometimes it is also able to assess a particular concentration of wildlife, particular concentration of species, etc. Next is a voice commands and voice synthesis. This property of element is been used when humans or a computer users wants to make themselves hands free in using the computers. So voice synthesis is nothing but a reaction towards the voice command which has been synthesized by the user. This is very much useful when the computer needs to be operated with the hands free. Computer works only through the commands recognized by the voice synthesis. Next is audio messages. This is a very good example of computer sending the information of as an audio memos. When we call about we record, we can discuss, or a music or the annotation can be sent from one device to another, that is audio messages. Video messages are similar to the audio messages. Apart from audio, here the concept of video is transmitted from one place to other place through those particular devices. Next, full oral live videos. This concept came into picture into everybody's life in today's technology. The full motion is we can capture a complete sequence of events, and it can be recorded and placed in one place or a storage space where we can see the continuous sequence of events that's been happening, or sometimes these events might be seen by others at the live, going live. The best example is the Facebook live or a YouTube live. So now we might be very much interested in knowing the situation happening currently in the pandemic, that is live webinars, live sessions that's been happening somewhere else can be watched from our house sitting in front of our computers. And next is a holographic images. Till now, whatever we discussed, all these technologies are representing the information on a flat plane, but these holographic images provides the virtual reality. When we say about virtual reality, it is the concept of feeling, means it takes us inside. It takes us inside and we could feel the reality of things. The best example that can be considered as like virtual objects. Now we know there are some cubes and other things. Let us consider this duster itself. When we hold this duster, we could see only this surface and this surface. We call it as 2D. We are not able to see the behind the duster, or unless and until we move this, we are not able to see. Now this holographic images gives us a feeling to view the three-dimensional view of an object. Now one more the best example that can be considered is one of the book publisher has a holographic sticker on its book. where there is a pigeon on it. When we slightly tilt that page or a sticker, we feel that wings of the dove is flying the sea like this, the waving. This is the importance of holographic pictures. And finally, the fractals. The concept of fractals was introduced way back in 1980s, but this importance of fractals has been used today, and this came into picture usage now very much. What is this fractals? Fractals are nothing but the technology which is based on synthesizing and storing the algorithms, and the outcome of those algorithms are the images created, like the waves. It might be a continuous wave, it might be a discrete waves. These are the 10 elements of multimedia. The first one is the fractional, second one is the document images, third one is the photographic images, next is a GIS image maps, and voice commands or the voice synthesis, audio messages, video messages, full motion, holographic images, and fractals. Now let us move into the next concept. The next concept is basic objects of multimedia. So what are the basic objects that constitutes a multimedia is? As we know, text, videos, images, holograms, animations. These are the few elements that constitute the basic elements of multimedia. Let us go with the text concept. Text is the primary or the basic element of a multimedia document. What is this importance? It is the multimedia element which stores very less amount of storage, and along with the text, if we use a numerical concepts, it forms a one more method of multimedial concepts, like adding number to the text could be a date, add number with the text could be a currency. These texts might be used in database, for the storing of names, retrieving of the different names, places, and accessing of it. So text is said to be the basic building block of a document. And again, you might heard about one more word called hypertext. Hypertext is something like an hyperlink. You might have seen in our web pages. You provide a link. When you click on the link, it navigates to you one more page where the details of that part is been described or displayed. In a similar way, hypertext is a text where when you click on that, you get a pop-up window, or sometimes it may navigate to a different place where the complete details of that particular text is been displayed. That is called the basic elements of a one more text element. Next, we talk about the images. Image is also considered as one of the element of the multimedia. Next, we will look into that. An image includes all the data types, but not the ASCII characteristics. When we say at ASCII characters, it comes to the text things. Next one is image as a one more property which is non-temporal in nature. What do you mean by non-temporal? When you capture a particular event through a video capturing device, the object is captured where it is stagnant. The images in the object do not move or change. That is called a permanent, non-temporal. When we say about a temporal, it keeps on changing. In videos, the things happen over a period of time. Here in the image, it is stationary, stagnant. This is the property of an image. Next, we look into the different hierarchical classification. We will go like this. Let me wipe out and take up the things. Images are classified mainly into three types. The first one is the visible images. And the second one is non-visible images. Next, the third is abstract images. This is also referred to as math functions. What are those things? We will look into it one by one. When we talk about the images, the first is the visible images. What is the visible images? The visible images are the images which are visible to the human being. What are the things that come under visible images? When you talk about visible images, it might be documents, it might be paintings, it might be a graph, it might be a blueprint, etc. like this. These types of elements are said to be visible images, or the images captured over the devices. These come under the category of visible images. Next, what are the things that come under non-visible images? First one is temperature gauge. And next is a pressure gauge. You might be knowing what is this. Non-visible images are not stored as images, but are viewed as images. This is the only important thing. I will repeat it again. Non-visible images are not stored as images, but they are visible but are viewed as images. The best example that can be considered is a temperature gauge. Let us consider the example of a thermometer, precisely the mercury thermometer, where when we keep up and check up the temperature, based on the temperature it keeps on deviating. It might be showing something like 93 degree or in between 94 something, and this is a balancing one, means it is slightly moving, variable thing. In the similar way, pressure things. When we take up a vehicle, we try to fill up air into the tires of a vehicle. If the needle shows, if you want to fill that at 32 points, when the needle comes around near 31 and 32, the puncture shop or a vehicle person, he removes off the plug and says, yes, it is done, 32 degree or 32 points. Let us consider one more standard example. When we are using an analog clock, so if the short needle of a clock or a short hand is pointing towards the number 9 and the long hand is showing or between 2 and the 3, it would be around 9:13, but what we say, we round it off and say either it is 9:10 or it has a 9:15. This is called images, but it is a moving, so it is not stored as an image, but it is viewed as an image. When we grab it, we fix it into one point and say this is the value. These kind of things are said to be non-visible images. Next is an abstract images. When we talk about abstract images, there are two things. One, it is continuous and discrete. When we talk about abstract images, these are not images at all. These are nowhere in the reality as images, but they are represented as graphs or a graphical pictorial representation. How are these done? These are generated by some mathematical equations by the computers. The best example that can be considered is discrete, the waves like this. These are called discrete. So at that instance of time, we take the value, we grab this and say this is a discrete, means an abstract, the outcome of a mathematical equation or a function. And when we talk about a continuous, so a continuous waves, which moves on like this is said to be done. So, this is the hierarchy of the images. Next, and the next topic that I would like to discuss is need of data compression. Now, in today's world, we are dealing with various multimedia elements like text, graphics, full motion videos, images, animation. Not only this, in association with all these things, audios and animations, graphical images and all these things, we are not alone using it. We are using in a combined form to form the representation and make a presentation more interactive. When these kind of multimedia elements are digitized, they create a huge storage space. This huge storage space is very difficult to maintain. And next one, when we talk about this storage property, the exact amount of the data is totally or directly associated with the resolution of the scanning. If the scanning resolution increases, obviously the storage of the multimedia data increases. Let us consider a resolution increases directly with proportion to the scanning. Let us consider the resolution of 200 dpi or a 400 dpi or a 600 dpi. As the resolution increases, the geometrical space of the image increases. For an illustration, consider a 400 dpi of an image or a still picture. It needs almost it needs almost 1,60,000 pixels, just an inch of an image with 400 dpi. What is dpi? Dots per inch. So, each element or each data is constituent of a particular pixel. Now, you imagine the amount of storage that is been required when we digitize all these kinds of multimedia elements. So, it is very important. So, what is the thing? So, if you do not compress it, what are the exact problem that is been caused by this uncompressed multimedia data? These uncompressed multimedia data needs to be used for retrieving, storing and also during the transmission. Sometimes it needs to be transmitted over a line, that is online. In those cases, it creates two major problems. One is a storage and next one is the transmission itself is a problem. So, in order to avoid or overcome these two problems, one has to compress this multimedia. What are we doing during the compression? When we talk about the compression, we are reducing the size of the file. Okay? When we are reducing the size of the file, it becomes easy to access, easy to store and also easy to transmit over a line. There are many compression algorithms used. Let us look into that. When we talk about a compression algorithm, what are the various algorithms causing the problem? I might be familiar with one algorithm, the other person or a manufacturer might be familiar with other standard of algorithms. So, it creates a mess with the usage of the things. Consider one manufacturer or a device manufacturer uses a particular algorithm for a compression and he releases his device. If his device is not supporting, when you are talking about the device as a manufacturer, it is indirectly I am talking with respect to software and hardware components. If it is not able to meet or support the compression standards provided by other manufacturer, then that multimedia element is of no use. So, a standardize has been fixed. So, what is that standard? The devices, that is the hardware and software, has to support particular standards. This is the need of having compression standards. So, a lot of standards has been fixed. So, in order to overcome the manipulation or manually fixation of different standards. So, generalized standards has been fixed. So, multimedia elements can be compressed using those standards, and it can be used by everyone anywhere irrespective of hardware and software configuration. Now, let us look into the types of compression. Non-lossy compression. This non-lossy compression is been achieved or used for images, where images, compression of images has been used to reduce the size without the loss of original data or any of the parameters. Second one, is the lossy compression. This lossy compression is the multimedia elements are compressed, especially here this is also used for videos along with the images. What happens here? The compression is achieved at the cost of losing some of the elements. Means the total quantity or the total information is not lost, but there is a reduction in the quality of the information. Here what we study? Here we study about JPEG, that is Joint Photographic Expert Group. Images, we study about MPEG, that is Moving Pictures Expert Group. In association with MPEG, we also study with MPEG 1 and MPEG 2 and MPEG 4, the basic of MPEG 1, MPEG 2 and MPEG 4 standards. Next concept that we would like to discuss here is multimedia databases. That is MMDB. What is this multimedia? As a regular convention of a database, this multimedia database uses to store the various elements of multimedia concepts, that is the text, graphic, images, moving pictures, animations, audios, etc. The main practicality here is one of the primary elements in association with others are represented to store the elements in the database. That is called multimedia database, but details will be discussed again in the subsequent chapters. The next topic that we are able to study is contents. The next topic that we are able to study is the contents of a multimedia database. What are the topics of multimedia database? First one, contents. First one, it is media data. The second one is media format data. Third one is media keyword data, and the fourth one media feature data. Let us look into the first one, media data. Here when we are talking about the multimedia database, in the database the first component is media data. Here we study about what kind of media is stored in that particular database. When we talk about the data, type of data, it might be a text, image, graphs, animation, etc. Second one, media formatting format data means here what type of formatting sequence has been used, means the sampling rate, transfer date and the schema of data replication. All these things are discussed in the second one, that is media format data, the types of format. Next, media keyword. Here the keyword that is used to represent the data is discussed. Let us consider image. When you talk about the keyword with respect to image, the description of image might be a keyword, or the date and time of that image might be a keyword. And finally, media feature data. When you talk about image itself, let us consider image as an example. What are the features of image? Here we discussed about the size, shape, and the texture of an image would be there. So these are the contents of multimedia. So concluding this, here we have discussed about the various concepts, the basic elements of multimedia, need of compression, multimedia database, and also the contents of multimedia database. These are the things I wanted to discuss in this session. Okay, thank you very much.